Look at the night sky, that milky band that cuts through the darkness, dotted with billions of twinkling stars. Our home, the Milky Way. Majestic, vast, real, or not? What if all of this, every star, every nebula, every planet, including ours, is nothing more than a projection, an incredibly detailed illusion, a cosmic hologram generated by an unknown source? An idea that seems like something out of the most delirious science fiction, but which finds disturbing echoes at the forefront of theoretical physics. Imagine that our three-dimensional reality, everything we perceive as solid and real, is just the image projected by a two-dimensional code on some distant frontier of the universe. A cosmic projector operating silently for billions of years, sustaining the illusion we call home. But what if this projector is not eternal? What if he can fail? What if at any moment, without warning, he just hangs up? What would happen to our holographic galaxy? Would the stars just disappear? Would the very structure of reality dissolve? Would it be the end of everything, a cosmic lights out that we wouldn't even notice, as our own existence will be part of the projection? Prepare to question the fundamental nature of your reality. Let's delve into the depths of holographic theory, explore the clues some scientists believe they have found, and speculate about the terrifying consequences of living inside a projection that may have an off switch. This isn't just a journey through the stars. It's an investigation into the very texture of the universe and the frightening possibility that everything we know is less real than we imagine. I know, it seems completely crazy, right? That kind of idea that makes your brain spin, but that's exactly why we're here. To explore the limits of knowledge, challenge what we think we know about the universe, and marvel at the most bizarre possibilities that science and imagination can conceive. If you also have this itch in your mind, this desire to understand the greatest cosmic mysteries, then you have arrived at the right place. How about being part of this exploration? Leave a like below to show that you enjoy this trip and want more mind-bending content. And if you haven't subscribed yet, click the subscribe button now and activate the bell so you don't miss any of our investigations into the most curious facts and the most shocking theories in the universe. Oh, and don't keep this madness to yourself. Share this video with anyone you think will also go crazy with this idea of a holographic universe. Let's unravel this together, so hold on tight, because we're about to pull back the veil on reality. Before we tear away the fabric of perceived reality, let's anchor our minds in what we believe to be solid, in our immediate cosmic neighborhood, the Milky Way. When we look up on a dark moonless night, far from the dazzling city lights, we see that faint whitish streak crossing the sky. Our ancestors called it the Milk Path, and for millennia, it was a source of myth and admiration. Today's science tells us that this band is actually the inside-out view of our own galaxy, a colossal disk of stars, gas, and dust. The Milky Way is a barred spiral galaxy. Imagine a gigantic cosmic weather vane. In the center, there's a dense and bright bulge, a concentration of older stars. And across this bulge, an elongated structure, a bar of stars. From the ends of this bar, majestic spiral arms emerge filled with young stars, nebulae where new stars are being born, and clouds of interstellar gas and dust. We, with our sun and our little solar system, are located in one of these arms, the Orion Arm, about 2/3 of the way out from the galactic center. We are not in the center of the action, nor on the desolate outskirts, but in a relatively quiet neighborhood. The scale of this structure is almost incomprehensible. The Milky Way's disk has an estimated diameter of about 100,000 light years. A light year, remember, is the distance light travels in a year, almost 10 trillion kilometers. So, to cross our galaxy from one end to the other, light would take 100,000 years. Despite this immense diameter, it is relatively thin, with the main disk only about 1,000 light years thick. It's like a CD or a vinyl record in cosmic proportions. Within this vast structure, it is estimated that there are between 100 and 400 billion stars, billions of suns, many of them possibly with their own planets. Beyond the stars, there are vast clouds of hydrogen and helium gas, the building blocks for future stellar generations, and dust made up of heavier elements forged in the hearts of dead stars. Deep in the heart of the galaxy, hidden by dense clouds of gas and dust, resides a monster Sagittarius star, a supermassive black hole with a mass millions of times that of our sun, whose gravity orchestrates the dance of the nearest stars. And surrounding it all, like an invisible halo, is the galactic halo, a sparse sphere of old stars, globular clusters, and crucially, an immense amount of dark matter. This mysterious matter, which we don't see and don't fully understand, makes up most of the galaxy's mass and is fundamental to holding everything together by gravity. Our galaxy is old, formed more than 13 billion years ago, shortly after the Big Bang itself. This is the Milky Way that science describes to us, our cosmic home, vast, dynamic, and as far as we know, real. But what if this description is just the surface? What if the most fundamental physics tells us that this impressive three-dimensional structure might just be a projection? We describe the Milky Way, our three-dimensional home, with its stars, gas, and dust. But now, prepare to have your notions of space and dimension completely shaken. The idea that our galaxy or even the entire universe could be a hologram did not come out of nowhere, out of a philosophical daydream. It has deep roots in one of the biggest challenges in modern physics, the incompatibility between the two theories that best describe the universe on different scales. On the one hand, we have Einstein's general relativity, the master of the larger scale cosmos, describing gravity as the curvature of space-time caused by mass and energy. On the other, we have quantum mechanics, the queen of the subatomic world, describing the bizarre behavior of fundamental particles and forces. Both work perfectly in their respective domains, but when we try to apply them together, especially in extreme situations such as the center of a black hole or the first moments of the Big Bang, the equations break, generating absurd, infinitely meaningless results. It's like having two perfect instruction manuals for different parts of a machine, but they contradict each other when you try to assemble the entire machine. Black holes in particular are a natural laboratory for this crisis. Relativity predicts a singularity at its center, a point of infinite density where space-time curves infinitely. Quantum mechanics, on the other hand, deals with information and probabilities and has a serious problem with the idea of information being destroyed forever by falling into a black hole, the famous information paradox. How to reconcile crushing gravity with the quantum world? It is in this context that the holographic principle emerges. Initially proposed by Gerard T. Hooft and developed by Leonard Susskind in the 90s, it was born from studies on the thermodynamics of black holes. They noticed something strange: the maximum amount of information that could fit inside a black hole did not seem to depend on its volume as would be expected in 3 dimensions, but rather on its surface area, its event horizon, the boundary from which nothing escapes. It was as if all the information about the 3-dimensional interior was somehow encoded on the 2-dimensional surface. Think of a common hologram, like those on credit cards or security seals. A complex 3-dimensional image is stored on a 2-dimensional film. The holographic principle elevates this idea to a cosmic scale. He conjectures, and it is important to emphasize that this is still a theoretical conjecture, not a proven description of our reality, that all the information contained in a volume of space can be described by a physical theory that exists only at the boundary of that volume. In other words, the 3-dimensional physics we experience could be an emergent description, a projection of sorts, of fundamental physics occurring on a distant 2-dimensional surface. This doesn't mean we are literally characters in a 2D movie being projected. The connection is more subtle and mathematical. The idea is that degrees of freedom, the fundamental pieces of information that describe a physical system, may be much fewer than we thought. Instead of needing to describe what happens at each point in a 3D volume, perhaps we just need to describe what happens at each point on the 2D surface that surrounds it. The amount of information needed to describe the universe would be drastically smaller, limited by the area of its boundary, not its volume. One of the most successful realizations of this idea is the ADES-CFT anti-de Sitter conformal field theory correspondence, discovered by Juan Maldacena. It establishes a precise mathematical duality between a theory of quantum gravity, specifically string theory, and a curved space-time called anti-de Sitter space ads of, say, 5 dimensions. and a quantum field theory without gravity, similar to those describing subatomic particles living on the boundary of that space, which would have 4 dimensions. It's like a dictionary that seamlessly translates between 2 completely different physical languages, one with gravity and more dimensions, the other without gravity and fewer dimensions. Difficult calculations on one side can become easy on the other. Although our universe is not exactly an anti-de Sitter space, this correspondence is powerful mathematical evidence that the holographic idea may be more than just an analogy. So to recap, the holographic principle is a profound theoretical conjecture, born of the attempt to unify gravity and quantum mechanics, especially in the context of black holes. It suggests that information about a 3D volume can be encoded at its 2D boundary. The ADA-CFT correspondence provides a concrete mathematical example of this duality. Important, this does not prove that we live in a hologram in the literal sense of a simulation, but it opens the door to a mind-bending possibility. The 3-dimensional reality we perceive, including our vast Milky Way, may be an emergent description, a complex manifestation of more fundamental physical laws operating in a lower dimension. The solidity, the depth, the vastness of space, everything could be a projection. And if so, where does this projection come from? And is it stable? A theory as radical as the holographic principle, which suggests that our 3-dimensional reality may be a projection, naturally raises a crucial question. Is there any evidence? Are there any signs, however faint, in the vast cosmos or in experiments here on Earth that point to this illusory nature of space-time? The short answer is there's no definitive proof. We are still in the field of theoretical physics and elegant mathematics, but there are some intriguing cosmic whispers and ingenious experiments that attempt to probe this possibility. One of the most cited lines of investigation comes from the study of the cosmic background radiation CMBE, the remnant glow of the Big Bang, the first light in the universe that we can detect. This radiation is not perfectly uniform. It has tiny temperature fluctuations that correspond to the primordial seeds of the structures we see today, such as galaxies and galaxy clusters. Some studies, such as the one mentioned by Revista Galileo, attempted to compare the characteristics of these fluctuations with what would be expected in a primordial holographic universe. Surprisingly, some holographic models which describe the early universe with fewer dimensions appear to fit as well, or even slightly better in some respects, to the observed CMB data as the standard model of cosmology, which assumes 3 spatial dimensions from the beginning. This doesn't prove that the universe was a hologram, but it suggests that the idea isn't immediately ruled out by our best observations of the early universe. It's a tantalizing clue, a distant echo that some interpret as compatible with a holographic beginning. Another approach looks for more direct evidence, trying to detect the pixelization of space-time. If our 3D reality is a projection of information stored on a 2D surface, some physicists theorize that space-time itself would not be continuous, but rather composed of tiny fundamental units like pixels on a screen. On the Planck scale, the smallest significant length scale in physics, incredibly small. If space-time is grainy or pixelated in this way, it might be possible to detect a type of fundamental noise, an uncertainty intrinsic to position measurements at very small scales. Experiments like the holometer at Fermi National Accelerator Laboratory in the United States were designed specifically to look for this type of holographic noise. Using high-precision laser interferometers, they attempted to measure whether the structure of space-time itself vibrates or fluctuates on this fundamental scale. Initial holometer results, published around 2016, found no evidence of this specific holographic noise they were looking for, setting stricter limits for certain models. However, this does not completely rule out the holographic idea, just some of its simplest or most specific models. The search for this fundamental granulation of space-time continues, with increasingly sensitive experiments being proposed. Another indirectly related area is ongoing research into the nature of quantum gravity and string theory. Although string theory itself is not the same as the holographic principle, it provides the mathematical framework, such as the ADA-CFT correspondence from which holography naturally emerges. Any advances in understanding string theory or in detecting phenomena predicted by it, such as extra dimensions or supersymmetry, although not yet detected at the LHC large, Hadron Collider could indirectly strengthen the case for the validity of the holographic principle it embodies. It's crucial to reiterate to date, we have no direct experimental proof that we live in a hologram. The evidence is indirect, theoretical, or based on interpretations of cosmological data that are still debated. Experiments dedicated to finding direct holographic effects have not yet been successful. Yet the fact that the idea persists and is explored by cutting-edge physicists, and that it fits intriguingly into some theoretical puzzles, keeps it a fascinating possibility. A whisper in the background of the cosmic noise that makes us ask, what if reality is much stranger than it seems? What if these clues, however tenuous, are the harbinger of a discovery that will change everything? What if our Milky Way is just a projected image? Who or what would be operating the projector? Here, my friends, we leave behind the safer shores of theoretical physics and plunge headlong into the ocean of pure speculation. If our Milky Way, if our three-dimensional universe is indeed a holographic projection, an image generated from information encoded on a two-dimensional surface, then the inevitable question arises, what is the projector? Where is this surface? And who or what is controlling this cosmic projection? Remember, from here on out, we are in the realm of what if, inspired by theory but not directly supported by evidence or proven equations. First, what could be this fundamental surface where our 3D reality is encoded? One intriguing idea is that this surface could be the boundary of our observable universe. Imagine a gigantic sphere surrounding us, the maximum limit of where light has had time to reach us since the Big Bang. Perhaps all the complexity we see within the sphere galaxies, stars ourselves, is in some way a holographic representation of information stored in this distant cosmic frontier. In this scenario, the projector would not be a literal machine, but rather the laws of physics themselves operating at this boundary, translating 2D information into 3D phenomena that we perceive as space, time, and matter. Another possibility, even more bizarre, comes from the connection with string theory and the idea of multiple dimensions. Maybe our 3D reality is just a brain, a dimensional membrane floating in a bulk or higher dimensional space. Fundamental physics would occur in this higher dimensional bulk, and what we perceive in our 3D brain would be a holographic projection, a shadow of these more complex interactions. In this case, the projector would be the dynamics of this higher dimensional space itself, and the surface would be the interface between our brain and the bulk. What about control? Who or what operates this cosmic projector? Here, the possibilities range from the purely natural to the almost mystical. It could simply be an inevitable consequence of the fundamental laws of the multiverse with no conscious operator. Just as gravity bends space-time, perhaps the laws of quantum physics, under certain conditions, naturally generate holographic projections that we perceive as universes. It would be a natural, impersonal process, part of the fundamental structure of reality. But the human mind loves to look for intention. What if it's not impersonal? What if our holographic universe is a simulation? Not necessarily a computer simulation like in the movies, but something more fundamental. Perhaps an incredibly advanced civilization living in higher dimensions or in a previous universe created our universe as an experiment, a study, or even a work of art. In this case, they would be the projector operators. Could they be watching us interacting? Or did they just leave the projection running and move on? Or going even further in speculation, what if the projector is consciousness itself? Some more philosophical or spiritual interpretations of quantum physics flirt with the idea that reality is somehow observer-dependent. Could the holographic universe be a manifestation of a fundamental cosmic consciousness, projecting itself as space, time, and matter? Could we be fragments of this consciousness, experiencing projection from within? These are questions without scientific answers, which take us to the limit between physics, philosophy, and fiction. There is no way of knowing which, if any, of these ideas come close to the truth, but thinking about them forces us to confront the nature of reality, and the possibility that the universe is much, much stranger and more mysterious than our three-dimensional intuition allows us to imagine. If we live in a projection, whether natural or artificial, a question becomes even more pressing and frightening. Is this projection stable? Can it fail? Can the projector be turned off? If our universe, our Milky Way, is a projection, The most disturbing question is what happens if the projector turns off. If the source of information that generates our three-dimensional reality fails, stops, or is intentionally turned off. Again, we enter purely speculative territory, an exercise in imagination based on the holographic premise. The consequences are so radical that they defy our understanding. One possible scenario is instantaneous disappearance. If everything we perceive, space, time, matter, energy, is just a projected image, then, without the source, the image would simply cease to exist. There would be no slow collapse, no explosion. It would be like turning off a cinema projector, the screen goes white, the image disappears. The stars of the Milky Way would not go out one by one, they would simply stop being designed. The planets would not disintegrate, they would disappear. We ourselves, as an intrinsic part of this projection, would cease to exist at the same moment. There would be no pain, no awareness of the end, because awareness itself would be part of the illusion that was undone. It would be the absolute and instantaneous end, a cosmic blink of an eye that would erase everything. Another possibility, perhaps a little less abrupt, but equally terminal, would be a dissolution of the structure of reality. Perhaps the shutdown is not instantaneous, but a gradual weakening of the projector or the information it processes. In that case, we could start to see glitches in the matrix, so to speak. The laws of physics could start to become inconsistent. The fabric of space-time could begin to unravel, perhaps with bizarre distortions, random energy fluctuations, or the very notion of distance and locality becoming meaningless. Stars could flicker erratically, change position, or their properties like mass or temperature could fluctuate in impossible ways. Matter could lose its cohesion, the atoms falling apart not because of nuclear reactions, but because the rules that held them together would be dissolving. It would be a different kind of apocalypse, not a sudden event, but a slow, chaotic unraveling of the fabric of reality, eventually culminating in nothingness or an unrecognizable state. What if the projector didn't turn off completely, but just failed? Did it start to display bugs or glitches? Could we experience phenomena that completely violate the laws of physics as we know them? Objects appearing and disappearing, events without an apparent cause, localized temporal loops. It would be a universe going crazy, the projection becoming corrupted. Perhaps these glitches could even be misinterpreted as supernatural phenomena or miracles, when in fact they are just artifacts of a faulty cosmic projector. But there's an even more disturbing prospect. What if we didn't notice anything? If our consciousness, our perception of time and reality is so intrinsically linked to projection, perhaps shutdown would simply remove us from existence without our having any ability to perceive the transition. Or perhaps if the projection is just a mathematical description of a more fundamental reality, the shutdown would just mean that that specific description is no longer valid. But the fundamental reality, whatever it is, would continue to exist, perhaps in a form we cannot even conceive of. We would be like characters in a book whose story is over. The characters cease to exist in the context of the narrative, but the paper and ink, the fundamental reality, remain. Whatever the scenario, the idea of a shutdown from the cosmic projector confronts us with the ultimate impermanence, not just of life or civilization, but of existence itself as we perceive it. If the Milky Way is a hologram, its stunning beauty and unimaginable vastness may be as ephemeral as light projected on a screen, dependent on a source we do not know and whose functioning we cannot guarantee. This brings us to a final question. If this reality is a projection, what exists beyond it? If our three-dimensional reality is a projection, a shadow, what casts the shadow? What exists outside the hologram? This question takes us even deeper into the abyss of philosophical speculation. If information is encoded on a distant two-dimensional boundary, what lies beyond that boundary? Would it just be a void from which information emanates, or another completely different reality, perhaps with more dimensions, governed by laws that we cannot even imagine? If our reality is a brain floating in higher dimensional space, then beyond the hologram is this multidimensional bulk. Could there be other brains, other projection universes floating in this same space? Could we in principle interact with them or with the bulk itself? The theoretical physics of string theory plays with these ideas, but they remain purely mathematical for now. What if we are a simulation created by advanced intelligence? So, beyond the hologram is the real reality of these creators. Would it be a universe similar to ours, or something unimaginably different? Would we be able to perceive or interact with this external reality, or are we forever confined within the confines of the simulation? Perhaps the very question, what lies beyond, is poorly formulated based on our limited spatial intuition. If fundamental reality is purely informational or mathematical, there may be no physical beyond, just different levels of description or complexity. The question transcends physics and enters the domain of metaphysics. We have no way of knowing, but the simple possibility that our vast Milky Way is just an image on a cosmic canvas forces us to consider that there may be much more to existence than we ever dreamed of. And so our trip down the cosmic rabbit hole comes to an end. For now, we explore the dizzying possibility that our Milky Way, our three-dimensional universe, is a holographic projection, an image generated by information on a distant frontier. We saw how this radical idea emerges from attempts to unify the laws of physics and how it connects to concepts like black holes and string theory. We investigate the tenuous clues and experiments that attempt to probe this illusory nature of reality and venture into speculation about the cosmic projector and the terrifying consequences of its possible shutdown. Do we live in a hologram? Science still doesn't have the definitive answer. Maybe it never will. But the question itself forces us to confront the nature of what we consider real. If everything is a projection, does that diminish the beauty of a sunset, the complexity of life, the mystery of a distant nebula? Or perhaps it gives us a new perspective, a sense of connection to a fundamental reality even deeper and stranger than we can comprehend. Perhaps illusion is just one level of reality, as valid and meaningful as any other. What do you think? Did this idea blow your mind? Leave your opinion here in the comments. We love knowing what you think about these crazy trips. And if you enjoyed this exploration of the limits of reality and want to continue uncovering the universe's most bizarre secrets with us, please show your support. Leave that thoughtful like, which helps us a lot to continue producing content like this. If you are not yet part of our community of curious minds, click subscribe now and activate the bell to be the first to know about our next cosmic adventures. And of course, share this video with everyone you think needs to have their reality questioned today. Thank you very, very much for your company and your open mind. It's your curiosity that drives us to ask these difficult and fascinating questions. Stay tuned, because the next video with another question that will make your brain spin is already appearing on the screen for you. Until then!